Hello everyone. Thank you for showing interest and joining for today's webinar focusing on use of AI in manufacturing. So, my name is Rahul Garkekar. I'm working as a group AVP with Stellarix and looking after strategic initiatives with Stellarix. I have been joined by my industry expert Deepak Jain, who looks after industrial manufacturing segment and efficiently delivers insights to its client. So before we start to actual presentation and today's topic, I'll just take a couple of minutes and introduce you to Stellarix. So Stellarix is an innovation study consulting firm which empower clients to achieve future readiness with sustainable growth and success. We are proud to have deep industry expertise, tech enhanced solutions, and resilient strategies together through hyper customized solutions. We serve as a trusted partner from concept to commercialization for our clients. If we look at our experience, so we are in the business for past more than 15 years. We delivered 2000 plus annual engagement. We are getting to our clients across the 50 countries, and we are delivering uh, pro, pro, intelligence or insights across 8 industries and 42 sub-industries. We have 1000 plus global stakeholders, which are across the geographies and hierarchies and divisions. If you talk about our expert network services, we are having 8,000 plus experts in our panel currently. Considering our niche, focusing, supporting clients in and preparing them for a future of their businesses, we continuously work in new age business areas such as advanced materials, energy storage, industrial IoT, sixth generation, and future of telecom. We have worked on industrial big data analytics, and several other topics that are relevant to for the businesses coming in the future. If we look at our strategic support, we support clients right from pre-conceptualization to monetization part. Wherein, if we talk about our horizon scan services, where we help client in identifying weak signal scan, technology commercial forecasting, we support them in innovation scan and investment opportunity scan. In terms of exploration, we validate the ideas through our proprietary idea funnel management. Also, we look through ideation mapping and product searches to ensure the relevance of innovation areas. We also conduct VOC analysis and market assessment to ensure the feasibility of ideas. We expedite the client's journey through technology and partner scouting. If we talk about the validation of ideas in materialization, we help client by doing best fit analysis of their ideas. We help them in developing buy versus build decision and risk assessment for technologies or solutions to come to market. We help client in understanding CapEx and OpEx assessment. We help them in designing strategic implementation and roadmap. And when we talk about commercialization or monetization part of our services, we help client defining go-to-market strategy. We help them understanding what is the value chain assessment across geographies, what are the profit margins, and what are who can be the suitable. We help them identifying who can be their suitable commercialization partners as well. So with this brief introduction about Stellarix, I now hand over the call to Deepak, who would be discussing about future of AI in manufacturing and how the resilient strategies can help you out businesses grow. Over to you, Deepak.
Thank you, Rahul, and good morning, everyone. Thank you for joining the today's session on AI in manufacturing. This is a topic that I have now moved from innovation lab to boardroom discussions, and now it is increasingly being integrated into the factory floors as well. So we are at a inflection point where AI in manufacturing is not just about automation and cost cutting. It is more about resilience, speed, and sustainability. Now, whether you are an end user who is struggling with reduced margins or a solution provider who is shaping the digital products, AI is eventually becoming the core part of your strategy. But along with this, there are certain challenges that either be it you are a solution provider or an end user you might be facing. Among all this AI hype, the major confusion is where should we focus? What are the real use cases of AI that are driving the impact? What does it take to move from pilot to scalable deployment? And to understand And to get the answers to all these, in this webinar, we have come up with the agenda where we will start by understanding the strategic landscape of AI adoption across manufacturing. Post that, we will move towards understanding the operational challenges and macro factors that are driving the urgency of AI implementation. From there, we will move towards the AI capabilities that actually move the needle in manufacturing, and we will dive into the real world value realization. Then we will look into the AI maturity curve, and we will help you understand what is the current scenario of the industry where the majority of SMEs or big or large corporates are standing. What is your position onto that curve? We are going to discuss about a self-assessment checklist where you can see the parameters and you can rate yourself to see whether your organization is ready for that AI adoption. Then we will further go deep into the AI ecosystem and see who are the different ecosystem partners here. And we'll see some of the real world AI products that are transforming the manufacturing and the key player strategies. Eventually, we'll jump into the gaps into the market to understand how it can be capitalized, be it from the solution provider perspective or the end user perspective. And we'll discuss a strategic framework that will help you understand whether to go for buying the solution, whether to build the solution. So we will help you in taking the buy versus build decision, and we'll be sharing that matrix eventually with you. So, not taking much time further, and let's start by zooming out and see what's really happening on the ground with AI in manufacturing. So, we are in the middle of a shift where we can see a lot of transformation trends going out, and it is visible globally where we can see that more than half of manufacturers are already piloting the smart manufacturing programs, and we see that around 20% have already moved from pilot to scaling stage, and there are around 20% of the organizations that have already that they have already built the plans for further investment into the AI. Along with that, there are certain growth adoption and skill trends are also ongoing where we can see that around 20% of the growth, year on year growth, is happening into generative AI and casual AI investments. We can see that there is a 14% increase in efficiency driven sustainability efforts that also translates into the AI integration for the sustainability. And to cater to all these things, the talks have increased at such a pace that now around 5% rise we can see year on year in the importance of analytical and AI skills for leaders as well, where they are also looking to enhance their capabilities to learn about AI. So there is an year on year growth towards the adoption and skill enhancement as well. So this was all about how industry is moving, what are the skill related trends going on into the AI in manufacturing space. But let's see some numbers. So in 2023, we saw that there was around $3 billion of the market for AI in manufacturing, which is anticipated to grow at around 16.7 billion by year 2028. That is 40% of CAGR, a very staggering growth. But the element to understand here is that this transformation, this 40% CAGR, is majorly being driven by two high impact areas, which is predictive maintenance and quality control. These two areas cumulatively cover the 60% part of this transformation, this 40% CAGR of AI. Let's look at the manufacturing and how what is the status of adoption in different subsectors. So there has been adoption across all the different business segments, be it automotive, electronics, industrial manufacturing, chemical processes, aerospace, textile, any sector you pick, and we can see some level of AI integration there. It's just a matter of fact that in some industries there is a large amount of penetration, and in some industries the penetration is still at a very nascent stage. But you see, there are some common areas where we can see this AI integration happening, where predictive maintenance comes at the top, followed by the process optimization, and then real time energy optimization use cases are also being tested by industries for AI integration. So AI is not limited to only high technology plants. Every vertical, every industry is tapping into is tapping into it and trying to gain some share of it, trying to integrate the AI into their systems. So why is this push for AI intensifying now? So we need to understand what are the major forces that are driving this urgency of AI implementation, AI integration, and we need to understand what are the key operational challenges that AI might solve or may solve or already solving. So if we see from the major forces, the macro forces that are driving this urgency, the major one is the supply chain disruptions. And based on the estimates and the Stellarix analysis, we saw that 70% of the organizations have faced sourcing challenges in year 2023. Along with that, the second major macro force that is skilled labor shortage. So there is a this is a two-faced problem, we would say. There is an aging workforce, and then there is a lack of skill. So aging workforce is one problem where there are not many people available to work into the manufacturing plants. But at the same time, when we think about integrating the AI into those manufacturing plants, then there comes the problem of skills where the employees, or maybe there is not a right amount of availability of AI skilled labor that can work or that can manage those AI powered systems. So this is a two-faced problem: an aging workforce as well as the AI powered skilled workforce. Because of all these two major issues, the input cost of the organizations is rising because aging workforce is increasing the input operational cost, as well as the supply chain disruption is causing another amount of large input cost for the organization, and that is eventually reducing the margins of the companies. Then there are sustainability mandates that has to be taken care by the organizations, because now sustainability is not an optional, it has eventually become a mandate for all organization, and that is putting another force pressure on the organization to integrate the AI. And then another important area that is forcing this AI adoption is the shorter innovation cycle. Now the consumer doesn't wait for a very long time, so organization need to go for faster NPI, faster new product introductions, new customizations into their product. And if the cycle is longer, then eventually they might lose their business uniqueness. So that's where AI integration is becoming very essential for organizations. Now, there are certain challenges that definitely AI can solve, and there are proven cases around that as well, which spans starting from the predictive maintenance to the real time energy optimization. So, it can help in reducing the unplanned downtime, be it quality related issues, the forecasting inaccuracy to understand what is going to be the future demand, what inventory an organization should have at their end, the optimization of the machinery, the process optimization, and the sustainability targets. So AI can help into solving all these challenges and help your businesses eventually grow. And because of this, only the 57% of manufacturers are seeing the value of AI and saying that adoption of AI is now business critical. It is not experimental anymore. So they already started feeling that it is essential to integrate AI into their business processes, be it at the manufacturing floor or on the backend side. Now let's take a strategic pause and understand what are the building blocks of the AI? What is the level of adoption, and what is the business impact that is being driven by these different areas where AI can be implemented? So here is a simple framework that we have built. On the x-axis, we can see that the adoption in manufacturing, and on the y-axis, you can see that level of business impact. So the sweet spot here is this quadrant one, where we can see the high impact and high adoption area, which includes the predictive machine learning, computer vision, and anomaly detection. These are the areas which has highest amount of impact and highest adoption as of now among those more than 50% of piloting to scaling stage organizations who are trying this. So these becomes the high adoption and high impact area for any organization, any manufacturing company. Then we have reinforcement learning and generative AI simulation and design, which are a high impact area, but as of now, there is very low adoption of these technologies, or we should say these AI areas. There are some low value, low impact areas which are currently into high adoption that has to be changed by the organization to have or to understand to realize the actual power of AI. These are the rule based automations. So these can be seen more or less in all the shop floors or any manufacturing company. Simple robotic process automations, basics AI for admin tasks, or basic NLP based chatbots. Now the challenge here is that the potential of these high impact low adoption area, it has to be translated to make them into high adoption area. At the same time, the area which are a high adoption and low value areas, these has to be translated into core value drivers. So how do we do that? Now, if you look at this quadrant where areas are already highly adopted but have a low impact, so we need to scale them from existing comfort zones to the core value drivers. To do that, companies or organizations has to do the horizontal integration of these AI elements into their operations. For example, chatbots can be introduced into the shop floor systems for issue resolutions. They have to go for data enrichment for better recommendation. They can connect basic NLP systems with the real-time production data. They have to introduce feedback loops to turn static rules into machine learning based adaptive systems. And they can eventually, or they can also go for plug and play AI layers over their existing MES and SCADA systems, which we can find more or less into every manufacturing organization in every shop floor. So these are some of the basic elements that can be tackled, can be implemented by organization to go from low impact high adoption area to high impact high adoption area. Now, at the same time, we need to also understand how to turn these potential high impact areas into high adoption areas as well without putting a lot of investment or without even betting your factory or changing a lot of things into the environment. So what organization can do is they can run the pilot programs with narrow and high rate of return targets where they can integrate reinforced learning for robotic arm optimization. Maybe that can be the one area. Similarly, they can go for toolkits that are being provided by hyperscalers like Microsoft, Google, AWS to lower the barriers of adoption, because these companies already have some pre-built systems that can help you in easily adopting, easily integrating AI into your manufacturing systems. Then you can go for simulation sandboxes for generative AI and reinforcement learning into safe environments. You can go for co-development with AI startups. If any of these or some of these are integrated or adopted by organization, then definitely it is going to help to move these specifically high impact areas into high adoption areas as well. Now, there are some of the core technological themes if we talk about overall about the AI that has to be understood by organization. So these themes are predictive machine learning and vision that has to be at the core for the organization, for any manufacturing company, because it is eventually going to drive the bottom line impact through predictive maintenance and line quality control or defect detection, or there may be many more other use cases as well. Then generative AI is emerging at a very faster pace. So you will have to find use cases of generative AI and reinforcement learning for your systems. For example, fast rising applications usually include AI generated designs. It can be simulation environments or autonomous decision agents can be integrated into the manufacturing floors. Then organizations can eventually further shift towards the AI native tool chains, where integration of AI can be directly done into MES and SCADA or PLM or ERP tools, which can shift the adoption from just AI as an accessory to eventually make it an embedded intelligence. So your existing systems already have or can be integrated with AI to make them an intelligent systems eventually. So you can have an entire ecosystem on your shop floors in your manufacturing plants to provide you with better decisions eventually. Let's look at some of the actual use cases where tangible wins have been seen, real measurable impact for AI has been seen. So it is not just experiments or pilots, but actual value has already been delivered by these use cases on the manufacturing show floors. So as you see here, there are 5 use cases which consistently lead the pack in terms of adoption of ROI. First is the predictive maintenance, which is perhaps the most mature and high adoption, high ROI areas. If you look from the use case and tangible win perspective, it has the capability to reduce the machinery downtime by 30 to 50% eventually. This can even help in generating a lot of ROI for the organization. Then second comes the computer vision based quality control, which has become the new benchmark for real time defect detection. So with medium adoption and strong ROI, manufacturers are reporting 20 to 40% reduction in scrap or maybe the rework, especially in automotive and electronics industry. The third one is process optimization, which uses AI to fine tune throughput across the lines. It often about delivering 10 to 20% improvement in the output without increasing the increasing your capex eventually. So without increasing a lot into the capex, by implementing AI for the process optimization, companies are able to gain 10 to 20% of increased throughput. So on the demand side, if we see AI-driven demand forecasting is still in the early stages, but it is proving its worth eventually into the volatile markets where inventory levels are dropping by 8 to 15%. Now, by having a better demand forecasting, companies need not to have a lot of or large inventory. They can have the inventory, or the AI can manage their inventory and have the right products, right equipments at the right time into their inventory. Then there comes the generative design, which is helping R&D teams to compress the development timelines and improve part efficiency. This may have low adoption as of now, but the impact on time to market and new product introduction is going to be significant eventually. So when it is integrated with simulation and PLM systems, definitely it can provide a significant amount of impact into the time to market. Excuse me. So what's the takeaway here? So these are some of the most tangible, or we should say CXO friendly use cases where manufacturers are seeing the real returns. So if you are starting or you are scaling AI, this is what you should prioritize. So what the essence of the webinar was to understand what should be the high impact and a high value area here. So these are some of the high value area which has high impact and already tested use cases as well, which can be opted by the organizations to start with their AI integration journey. We can see some of the use cases coming from the end users where we see that GE Aviation, they have their predicts platform which aggregates sensor data across the fleets to forecast maintenance needs. And as a result, it claims that it can provide 30% reduction in unplanned engine failures. It can increase engine lifespan by optimizing the maintenance schedules. Similarly, we have use cases coming from Siemens as well as the Bosch as well. Then there are use cases coming from the solution providers as well. Companies like Third Eye, who have built CV system for paper mill defect detection. Their use case was they have installed a deep learning powered deep defect detection system at a paper mill, which uses line scan cameras and edge interface. As a result, company claims that they were able to provide 93% accuracy, 30% reduction in rejected products, and 25% improvement in the product quality. Though these are just the claims, but based on the multiple instances of implementation, we can say that more or less they falls into the right set of criteria, the right range. Because we have seen the implementation of AI, we have seen how it can drive value for organization. So most organizations overinvest in experimental AI and underinvest into the proper high value areas. For example, like quality, maintenance, throughput optimization. This is where you can understand that which are the high impact, high value areas that has to be capitalized first, prioritized first before jumping into those experimental areas. So it's all about realizing the value, then doing the investment again and again. Now we need to understand what are the all steps into the AI maturity, and organization need to evaluate where they are currently and where majority of the SMEs are falling. So what we can see here is a six-stage AI maturity curve, which is built from real industry engagements and grounded business realities. So the initial stage zero is passive operation. This is where many traditional factories still operate. There's no real-time data, minimal digitalization, and little visibility across processes here. Then there is a stage one where digital awareness starts building, data collection starts happening. This is where manufacturers begin capturing the data through some of the IoT sensors that they might have implemented in their systems. Then there is stage two where pilot AI initiatives starts. At this stage, we can see some experimentation. Predictive maintenance models may be tested by organization on one line, some proof of concept for vision-based quality control. Then we move towards the functional scaling, where AI eventually becomes the more structured. We see adoption across functions like maintenance, supply chain, or quality. Then it moves to the stage 4 where AI is scaled into integration. This is where leaders start pulling ahead. AI is integrated across different plants. It is linked to your MES ERP systems. It is tied to your business KPIs. This is where cost, change resistance, and skilled labor availability becomes a major point, a major friction point. Then there is a stage 5, autonomous and prescriptive AI ops. This is where a handful of players are available. For example, companies like Tesla and BMW iFactory, they are already doing pilots at this scale. So these are typically early movers with strong hand into their digital initiatives. And then there are self-evolving AI operations. This is like where AI itself is self-aware and can optimize everything. So we have not seen anybody exploring that areas as of now into the manufacturing sector. It is like having the AGI at hand, where your entire machinery have their own brain and they can decide, take decision by themselves, what to manufacture, when to manufacture based on the demand forecasting and everything integrated into a single ecosystem. But now what is interesting to see here that majority of the SMEs and corporates currently stand into the stage 2 and stage 3 area only. Why so? Because this is where companies are stuck into pilot cases and rollouts. Conceptual thinking usually starts around stage 5. It exists, but especially in automotive and electronic sector only. Manufacturers have the technical capabilities to scale, but the real barriers are cost justification, talent gaps, and internal alignment. So as we move forward, we are going to discuss about how to break through these friction points. So from stage 2 to stage 3, there is a different mindset of manufacturer that requires a mindset shift when you move between these stages. These are the maximum friction areas. So when you were at the stage 0 or stage 1, you the organization used to think that maybe we don't need AI, or maybe we are collecting data and organization not sure what to do with the data. But when they have passed this barrier, initial barrier of mindset, then they move to stage 2 and stage 3, which is where they start testing the AI into their plant for their use cases. But then moving from stage 2 to stage 3 becomes the cost intensive area. That is where companies say that they can see the value and they want to replicate it to across similar lines. But there are multiple friction points that play a role here for organization to shift from stage 2 to stage 3 or stage 3 to stage 4. When you are at stage 2, you are in the experiment and the pilot stage, then the question that comes to organization or manufacturer's mind, decision maker's mind, is that is the ROI worth enterprise wide rollouts? Because scaling from stage 2 to stage 3 is going to require a lot of investment. The investment is going to be into cloud and compute cost, maybe integration cost with legacy systems. It can be licensing of AI platforms, edge devices. There are multiple front of investment that has to be done when you are moving from stage 2 to stage 3. But when you have passed this umbrella and you are at stage 3, then eventually you are above the investment related barrier now. Now moving towards the stage 4 becomes very critical, where decision makers have the question into their mind that do we have enough talent to build, scale, and sustain these AI systems. This is where companies need to have a lot of data engineers, machine learning engineers, AI aware process engineers, change agents that can align people across the plants to move from stage 2 to stage 3. Now, once you have moved from this stage 3 to stage 4 by passing the talent gap as well, then it becomes a bit easier because now investment is not a problem, the talent is not a problem. It's just the adoption of AI, seeing the use cases, and eventually keep adopting, keep improving into those systems to move towards the stage 4, stage 5. Then comes the stage 6. This is something that is unexplored area, and probably the technology is not at that stage where it can build that level of system as of now, but soon it will be here. We can see that generative AI is increasing at a very faster pace, and it seems like that in next 3 to 5 years we might have AGI use cases into the market that may eventually drive the adoption towards the stage 6, that companies might start piloting at stage 6 level as well. Now, you need for any organization to understand whether they are ready for the AI, their organization, their show floor is ready for the AI adoption. You need to have a clear strategy. You need to understand and assess yourself whether you or your shop floors are ready, have the all required elements to integrate the AI. So we have prepared a 5 dimensional matrix, I would say, where you can evaluate yourself and see how many check marks you have for your organization. So it starts with data infrastructure, where organizations should ask whether the organization have centralized access to relevant operational data, whether they have clean, structured, and time-stamped data with them, and to check whether they are ready for data infrastructure, they can see whether they have sensors and IoT in place, whether they have real-time data pipelines, whether they have historical data available. This will help them understand whether they are ready with the data infrastructure. And this is essential to understand all these 5 elements, because it is eventually going to help you decide whether you are ready to adopt AI or not. And if it is not there, then first thing is to have all these things, all these 5 elements into place. Then second comes the talent and skills. So does the organization have in-house data science or machine learning expertise? Are your company's line managers and engineers have some AI awareness already? The readiness markers here can be, if you have identified the AI champions or AI engineers into your existing employee pool. Are there cross-functional teams in place already? Do you have any training programs already running to make your employees aware about AI integration? Then there comes the process maturity. So are your processes digitally mapped and standardized? Is organization, or can an organization quantify KPIs for optimization? So organization need to think whether they have their processes standardized already or they are scattered into multiple elements, because this is when, if the process is not mature, it becomes really difficult to implement the AI. So you must have some digital SOPs. There should be measurable process KPIs. There has to be integration with MES and ERP systems. Then organization, when you have passed the data infrastructure, talent, and process maturity dimension, then you need to see whether you have the clarity about the use case where you want to implement the AI. So does organization have already identified the high impact use case for themselves? Has the organization aligned AI initiatives to their business priorities? So this is essential. Do not directly jump into the investment into AI, but you need to understand what will be the high impact, high value area, high value use case for you. Whether it is aligned with the business's overall priorities, overall goals. If that is set, then we can say that organization has a use case clarity and it can move forward with the AI adoption. Then the last and important element to see whether you have the technology stake at place to deploy the AI. So does the organization have tools, platforms, partners ready to deploy AI? Is there a clear deployment and support path, support plan you have already in your hand, in your mind? This is where you need to see whether you have chosen the right set of AI platforms, AI tools, whether you have the cloud or on-premise infrastructure to manage the data pipelines, whether you have the vendor ecosystem already at your hand, or you have at least shortlisted the vendors who are going to help you in integration of AI. So we are going to share this self-assessment checklist with you as well post this webinar. This is eventually going to help you evaluate yourself, see whether your organization is ready to implement AI or not ready to implement that. Now that we have seen how manufacturers are progressing on the AI maturity curve and what are the tangible wins that are visible, let's take a step back and look at the broader ecosystem. So AI is AI in manufacturing is no longer just about having the internal capabilities. I mean, it's about navigating a growing and rapidly evolving ecosystems. And we see that there are these four layers of these ecosystems. If we look from the core AI technologies perspective, neural networks, computer vision, generative AI, reinforcement learning, or NLP for human machine interfaces, these are the core AI technologies that has to be considered or something that should be known for the companies. And then there are AI application areas, AI application areas, for example, predictive maintenance, quality inspection, supply chain optimization, energy efficiency, production scheduling, human robot collaboration, and there are multiple solution layers and enablers that help build this entire ecosystem. So we have divided the ecosystem players into seven different categories so that we have a clear distinction and organization also can get a clear idea which one to pick for which stage based on their availability at the AI maturity curve, or maybe when they are building their internal plan of AI adoption. There are some real world AI products use cases that we have come across and gathered from the key players which are building this AI infrastructure. For example, companies like Siemens that they have industrial copilots already, which provides AI capabilities across discrete and process manufacturing. Then there is ABB, which have Ability Unix, which combines the power of industrial analytics and AI into enterprise grade digital platform suite. It helps to make informed decision, boost operational efficiency, and predict maintenance needs. Then similarly, there are solutions provided by Rockwell Automation, Schneider EcoStructure, Immersion, and Mitsubishi Electrics. So more or less, all the major solution providers have at least some kind of solutions available for end users to integrate into their systems for majorly around the predictive maintenance and quality optimization. So, what are these key player strategies? We see that Siemens and Nvidia have expanded their partnerships to enhance AI in manufacturing by integrating Nvidia's AI in accelerated computing with Siemens Accelerator. Similarly, Schneider has also partnered with Microsoft for integrated the solutions, the Microsoft solutions and Schneider. They are partnering for automated automation expert platform. The copilot that they have built is to use generative AI to provide system recommendation and predictive maintenance alerts. Then UiPath and Nissan has also collaborated. So that collaboration is for its robotic process automation software and its ability to automate it repetitive digital tasks. Its AI computer vision can be combined with application program interface to automate clerical processes. So there are different strategies, and if you see in common companies, the end users are collaborating. For example, Nissan, they are collaborating with the solution providers to implement those solutions, and the solution providers are connecting with the AI infrastructure providers. They are partnering with them to bring these kind of solutions into the market for end users to use. Even startups are not behind. There are companies like Bright Machines, Hilo, which have been found in the last decades. They are coming up with some very smart solutions. The Bright Machine has smart robotic solutions and software which are related to AI driven softwares to optimize product designs for automated assemblies, and they are already having collaborations with companies like Microsoft. Hilo also has a collaboration with Schneider Electric to integrate their advanced processors within its solutions. Schneider is going to gain significant improvement in manufacturing tasks, including quality control, yield optimization, enabling real-time high accuracy data analysis at the edge by integrating the Hilo's solutions. Now, at we are moving as we are moving towards the end of this webinar, it is essential to eventually understand what are the technology and solution gaps and what are the opportunities available for solution providers and for the end users as well. If we look from the technology gaps perspective, they are categorized at the forefronts. It can be infrastructure and architectural gaps, it can be application or deployment gaps, it can be human AI interface related gaps, and it can be ecosystem and innovation gaps. So from technical technology gaps, if we see edge native inference, model versioning, industry specific AI models, data governance, these are some of the infrastructure gaps that we have observed at the organizations in the manufacturing departments. This is why there is a challenge of AI adoption. There are application and deployment gaps like AI model generalization, weak AI digital twin integration. From human AI interface gaps, there are black box AIs, lack of explainability, weak multimodal HMI integrations. And from ecosystem perspective, we see that there are fragmented tooling across ecosystem. There are no benchmark datasets, no low model transferability. So there are a lot of technological gaps which can be leveraged by a solution provider to provide the right set of solution to end users. Then there are solution level gaps as well. From infrastructure perspective, we see that unified IoT OT data platforms as cloud orchestrations, ML ops at plants, brownfield compatible AI modules, natural language operators, AI as a service platforms. These are some things which are not readily available or available in a very limited capacity. So with these gaps, what are the opportunities for solution providers? This is an interesting part where solution providers actually get the valuable outcome, understand where they can provide value to end users, what kind of solution they can build. So from the infrastructure perspective, they can offer pre-integrated edge plus cloud AI stacks for manufacturing. They can launch industry specific AI model hubs. They can build secure auditable MLOps platforms which are tailored to regulated manufacturing. From application standpoint, the solution provider companies can develop factory templates for rapid AI deployments. They can go and provide plug and play kits to end users with pre-trained and anomaly detection capabilities. Then there are additional elements that can be provided by the solution providers in usability and human AI interface, which is like launching AI UX design frameworks for factory floor users, designing of safety certified override systems. Then ecosystem and innovation gaps can be fulfilled by creating AI marketplaces with pre-trained models, by offering skill building platforms as part of solutions. Similarly, there are a lot of actions that end users can also take to have this AI integrated into their systems. They can invest in robust model life cycles. They can work with vendors who support data traceability and as native operations. They can standardize factory equipment data models to ease AI deployment. They can push for interoperable AI modules across their legacy systems. They can train operators on AI trust and oversight principles. They can co-design operator interfaces with real-world teams, be with the solution provider team. They can have partnership with solution providers to eventually bring the real-time solutions into the market for their use cases itself. They can participate in open innovation pilots with trusted vendors. So these are some of the use cases, actionable items that end users has to or can do at their end, and there are few opportunities for solution providers that they can use to provide credible solutions to the end users. Now this is the last slide for the webinar where we are building a pyramid. We are helping you from the pyramid by saying that how you should decide whether a solution is the right AI solution for you. So what you need to do, you need to go from bottom to top. You need to first define the use case. You need to understand what is your current technical environment, your MES, ERP systems, your legacy systems. You need to move and understand your resource readiness. You need to see the deployment urgency, and eventually you will have to take whether to buy the solution, whether to build the solution, or whether to do a partnership with any solution provider to build these kind of solutions. So it's going to be a buy, build versus partnership decisions, and we have prepared a decision matrix that will be provided to all the webinar attendees once they have requested through the webinar attendance form. And along with that, there is a solution evaluation matrix as well, where once you have decided that this is the area where AI has to be implemented, Then you can identify the multiple solution. You can evaluate those solutions as well, that which solution is going to be the right fit for you. So this is all from this webinar. This is all I wanted to bring out in front of you to make you understand, to clear the confusion, that what are the high value, high priority, high impact area where organization should go and implement the AI as a first go. Thank you.
Thank you, everyone. Kindly share your questions in a chat box, and we will share with you the responses for all the questions along with the matrices that Deepak mentioned about in next 48 hours. Thank you so much for your time. Have a great rest of the day.